So our problem statement was to build a model to predict the electrical energy output of a combined cycle power plant. Our dataset has a total of 9,568 rows and 5 columns, with the target column being PE, which is the net hourly electrical energy output of the power plant. So the first step here is to determine which modeling approach would be the best to be used here. Since the dataset consists of structured data points or observations organized into features, we will choose a supervised learning algorithm, and in this case, a regression model, because our target output is numerical. The second step here would be designing the model, which includes selecting features, choosing the algorithm, setting the hyperparameters, and finally training and evaluating the model. But since I'm using Google's AutoML to run my model, the beautiful thing about this tool is that it automatically performs most of the work in the background to simplify tasks for us. This includes finding the right algorithm, setting and fine-tuning the hyperparameters, comparing models, and evaluating the model on the test dataset. So I'll let the tool work its magic and throw out the output metrics later on. So before building and running the model, first I created an account on Google Cloud and set up a new project called ML for Product Managers. So we can see this here, ML for Product Managers. And there are two particular tools I leveraged for the rest of the process. The first one is BigQuery, which is Google's data warehouse where all the information is stored. Here's my BigQuery dashboard. And I uploaded the data set into this specific folder. This is my data set with 9,568 rows. And then I navigated to the second tool, which is called Vertex AI. Here, I created a data set to import the information from my table that I have stored in BigQuery. So this is my data set that I will be using to train the model. For training purposes, I go to training and click on create to create model 1. This is my first model. The way I created it is I chose the data set, selected my objective as regression, and then chose my target column as PE, and went with the default data split values of 80, 10, and 10 for training, validation, and test data sets. And then I finally chose to go with all variables just to make sure that I have a good estimation of the baseline model performance with all the variables. Here, I chose my evaluation metric is minimizing RMSE because we are predicting the output of a power plant, right? And we want to make sure that we are capturing more extreme values accurately. So I continue and I start training the model. So once the model gets trained, it gave me, it throws me evaluation output metrics in the form of MAE, MAPE, RMSE, RMSLE, and R square. So if you can see, the RMSE here says 3.72, which seems to be decent, but we still don't know if that is the best or not. But the R square is 0.964, which is very close to 1, suggesting that we potentially have a great fit for the model, and the model is able to explain most of the variance in target values. So I also noticed that the feature importance chart ranks 80, or my temperature, as the feature with the most importance, or the feature that had the most impact on training the model, and RH as the feature with the least impact on training the model. So I decided to go back and train another model, and this time without the feature RH, which had the least importance in training the model. And here I see an RMSE of 3.149 and an R square of 0.966. At this stage, I want to compare the evaluation metrics from both my models to check which one yielded better results. So I go and select both my models and look at the comparison metrics here. I notice that model 2, which is the one in blue, is slightly better than model 1, which is the one in pink, across all my evaluation metrics. It had lower error metrics, including RMSE, which we were trying to minimize. And it also had a higher R squared, which indicates that the model is able to better explain the variance across the features. So I decide that my model 2, which has 3 features excluding RH, is way better than my model 1. And now I can continue to fine-tune this model and deploy it to any endpoint. Thank you.